Hello everyone, how are you? Hope you are all doing fine. Today I will explain to you part 2 for the cylinder wall. As we mentioned before in the previous link, the explanation, I will make a quick revision now for the cylinder wall. As I said, we have the cylinder, the Q, the heat transfer, and there is some parameters, right? We got that the conclusion for the conduction equation is Q equal 2 by K. K is the constant for the conduction, L for the length for the cylinder, and delta T the temperature difference between inside and outside, divided by length, radius outer, or outer radius and inner radius. And then if you want to calculate the resistance in case of conduction, this will be the rule. Ln R outer divided by R inner over by 2 by KL. In case of convection, Q equal HA delta T, where R equal 1 over HA, and A is the area, which equal by DL. Here we'll find that the conduction is you calculate it using the radius, and here you calculate the diameter. Don't get confused when you get the equation or you get the problem when you are writing the given and you write the givens. The first thing you write radius equal diameter equal, right? And what is the difference between radius and diameter? If this is the circle, these are the radius, and this is the radius, and this is the diameter. Okay, so now we will go through the sheet number 2 for the solution. Sheet number 2. A stainless steel pipe with length 11 meter and has inner diameter 0.3. So you write the length equal 11 meter, diameter equal 0.3, radius, diameter divided by 2, you get the radius. And then he tell you that the outer diameter is 0.35 meter. So you get the D outer 0.35, and the R outer is what? This divided by 2, you get the R outer. The temperature of the inner surface of the pipe is 50 degrees Celsius. This means that T inner temperature inside is 50. The temperature for the outer surface is 40, but T outer equal 48. The thermal conductivity of the stainless steel equals 613. What is the required? Calculate the heat transfer through the pipe. Okay, we have the Q. We write down our equation. It is direct substitution. You make a direct substitution here. You get the what? For number 2. A 3 meter length of a pipe with inner radius 0.3 meter. Here he give us the radius direct, and the outer radius is 0.04 meter, has an outside temperature 121 Celsius. The heat transfer rate is 300 watts. Find the inner surface temperature. Assume that the K, or the constant for the conductivity, is 141. So easy. We will write the givens, the length, the radius, the T inside, and the required is the T inside. We here use the equation. You will find it that you make a direct substitution. Number 3 tell you that Water flows at 50 degrees Celsius inside 1.25 centimeter diameter. So here the first thing that you have two tricks that is given by diameter, you have to get the radius, and the other thing that it is in centimeter, you have to get it by meter, such as that HI equal 3500. So here you have the inner diameter with conductivity or convection HI convection 3500. The tube has a wall thickness of 0.8. You have a thickness for the wall. You have this and this as I mentioned, and there is a thickness for the wall like this. So here the R inner with HI is given, and then you have this thickness 0.8, so you can calculate what the R outer, and what you will find this thickness there is conductivity, and from outer to the atmosphere is what is convection. So here we have a mixture between the three resistance. The first resistance from R inside to the here, it will be what as a given it is convection, and then through the thickness it will be what it will be conduction. Then from the outer to the atmosphere it will be convection again. So we will draw here circle 1 and cylinder 2, R1, R2, R3. If you didn't understand the idea, you can get the idea of the problem from the givens. You will go through the givens. First one, HI, it will be what for convection. The second is for the conduction. The third is given for HO. The outer is also for what? Convection. So if you didn't get the idea or understand how it goes, you can get it through the givens. Calculate the required here, the heat loss per unit length, and the surrounding temperature is 1220. So here when you find a mixture, the first thing to make is the diagram. R1, R2, R3. R total, it will be the summation for the resistance. You write down the diameter and you get the radius, and since the thickness is 0.8, so you get the R2, it will be the thickness divided by multiplied by 10 power negative 3 to get it transferred to meter, and then add the summation for R1. You get R2, and it is given the constant. Calculate the heat loss per unit length. It will be he wants Q over this is the requirement. Since Q equal delta T over R, and the temperatures are giving the inside and outside, it is given here 50 and here 20. So first thing we have to calculate the resistance and make the summation. The R1 it's a convection. We take here the resistance for the convection. It will be H over 1 over HA, and in case of conduction it will be like this. While writing down the numbers, make sure you didn't forget anything. And for example, I forget here the 10 power negative 2 and I recalculated all. Make sure and remake revision for every parameter.